Welcome back. Today's project involves making the best of a bad, or of a poor investment, we'll say. I know I'm not the only, home shop machinist that's taken a gamble on cheap import tooling and lost. Sometimes it's really good. I've got a set of 1, 2, 3 blocks that are actually pretty spectacular. But it was not the case with these. These are TTS tool holders to go with my mill. And they hold ER20 collets. The taper itself is nowhere near concentric. The collets themselves are even worse. But I'm going to do my best to, what's the saying, make a silk purse out of a sow's ear. And use these to solve, I guess, more of an annoyance than a problem over on the mill. So I'll get things set up over there, and I'll bring you back. All right, so here's the setup. I just drilled a hole. I don't want to tap it. M6, but I suppose that really doesn't matter. The way I normally do this now, mind you, I don't have a tap follower, and that was going to be a future project. I still might make one for the lathe, because this doesn't really apply to the lathe, but I digress. So the current method for tapping a hole is turning the chuck in the right direction. Getting this as tight as I possibly can. Unlocking, and then putting the mill into neutral. A little bit of lube. And let's see if I can do this. Just turning the chuck by hand until the tap starts to slip in the jaws, which it probably won't because this is thin aluminum, but you get the idea. And then once it starts to slip, undoing the chuck, getting it up out of the way, and then finishing the rest by hand. And that's all well and good for a couple holes here and there. But if I have a bunch to do, that's cumbersome as hell. So the idea I've had, let me go ahead and get this out of here, is to use, excuse my reach, this ER20 holder and the collet basically as a tap guide. I can bring this down, have the collet not snug, but tight enough so that there's no play, and use it to guide the tap down. Now, a pre-tapped hole, it's relatively easy to turn, but that's not always going to be the case, especially for larger taps. So my idea is to make a wrench that picks up these two flats right here. My original idea was to make something with, something that replicates a normal tap holder. I guess sort of, 2 handles on either side, and then like an open-ended wrench, I guess, basically in the middle that would catch this and I could turn it. And then I thought, well, I need something to be able to tighten the collet nut and to be able to hold these flats. This is, I forget what size this is, but I know this nut is 30 millimeter. I don't have a 30 millimeter wrench. I was like, well, I can just make a 30 millimeter wrench. And then I thought, well, I'm going to make that wrench, I'm going to make this wrench, and and I want something that has 2 handles on either side. I'm going to try and make the wrench that holds these flats a little thicker and put a groove in either side, and have this wrench be thinner and fit into that groove so that I can end up with a handle on either side of the tap so I can drive it in evenly, and I can still have 2 wrenches to tighten the collets and not just have a whole bunch of tools extra tools laying around. So to that end, I'm going to go ahead and cut some steel and get everything else prepared, and I will bring you back for that. So I figure this is as good a time as any to show off a new toy. This is a touch probe I got to use the functionality for that in Touch DRO. I just picked it up off everyone's favorite Chinese import site. It wasn't very expensive, like maybe $20–30 at most. I think they have ones now even for $10. It's all the same thing. But I've got it in a 6mm TTS holder, and I'm going to use it to find the center of this piece. So plug it in. It's not actually USB, it's just uses that for power. Bring it down, hit the touch probe on Touch DRO. And just slowly bring it in. Okay, that's one side. And we tap the other side and Touch DRO. Okay, back off, bring it up. And that should set our origin. Okay, that looks in the middle. I've already zeroed on the edge here when I flatten this off. So I'm gonna get this out of here. Go ahead and put this back in. Okay. Perfect. Okay, that's one side. Perfect. Okay. Now on to the next stop. So I figured this would be a good opportunity to show just how much more quickly this probe can help me find my origin of a part. So for this next operation, I want to find the end of this face and then center up between these two faces. So in order to do that, go into the probe, hit the end. Okay. One side. And the near side. Okay, set my origin. Okay. And that pretty much puts me exactly where I want to be. Centered here. And the touch DRO automatically compensates for the radius, or the radius of the end of the probe, which is a 2mm probe, so 1mm. So for this operation, I can get this out of here. Be using 1/8 inch end mill. So go back to that. We want to be 62.5 thousandths off the end to account for the radius of the tool. Go, we'll re-zero here. Lock Y. And I want to take about 155 thousandths off of each side. So do that. Whoop. Helps me unlock the spindle. We'll feed down 25. Yeah, I'll take that. Nice tight fit. And I'll round these corners over so that they fit into the rounded corners here. Okay, the only thing really left to do is to make these look more wrench-like. So I'm gonna do that. So I'll use an end mill to put a couple of holes through here, and then bandsaw the rest of that off and finish it up on the belt sander. Actually, I have a better idea. I'll meet you over at the Van Norman mill. So I've got you over here at the Van Norman. It's a universal milling machine. It's a really, really cool machine. I'll do a video about it in more detail in the future. But for now, what I'm doing is removing all the material that isn't the handles of these wrenches. I want them to be about 1 inch wide. The thin piece needs about a 1/2 inch removed from each side, and the thicker wrench needs a 1/4 inch removed from each side. I'm just going, there's no critical dimension here. I'm just going to the line, taking a 1/4 inch at a time on this piece, and I don't know, we'll see what happens with the other one. Good enough. On to the other one. Here for the last op, or at least the last machining op. I'm gonna thin this handle down so that it's the same thickness as the other one. Got a big old 3-inch wide slab mill in there. Unfortunately, I can't mow away as much material with this because it's just so wide, but do what I can. And after this, it's off to the belt sander, so let's get it done. No, I think you get the idea. I'll bring you back when I get to the belt sander. Alright, last step is to grind these and round the ends, around the sides. Just make them more comfortable, and that should be it. Got it close. I'm gonna finish it up with a file. Meet you back at the mill. All right, I guess it's time to try it out. So the situation, will be just drilled your tap hole, pop out the drill bit, and probably have it set up in advance, but you can set it up now. So with the appropriate size collet, it's our M6 tap. I just have this collet tight enough just to hold it up. Okay. So now bring the head down. Leave myself a little bit of room. Tap is loose. That in there. That in there. All right. I'd say it works. And also that another nice thing about doing it this way is with smaller taps, you can actually just use the collet holder itself to turn. So this way you have a nice bit of feel here and you're not using the big handles without, basically make it harder to snap a small tap if you just do it this way. But, well, it works. I'd say that's another successful tool. Thanks for hanging out with me in the shop, and I'll see you on the next one.